Let's talk about finding the current in electrical circuits using matrices. For example, determine the three currents I1, I2, and I3 in this circuit. This is how we represent a battery, you can see it here, and this is how we represent a resistor. It resists the flow of current. Kirchhoff's voltage law: in one traversal of a closed loop, the sum of the voltage changes equals 0. So for example, if we start here and go all the way around, the sum of the voltage changes will equal 0. It's named after the German physicist Gustav Kirchhoff. Let's start with the loop on the left half of the diagram, this loop over here. The starting point and the direction we choose for our traversal of the closed loop are arbitrary. We're going to begin here, arbitrarily. We will choose a clockwise transversal. This is not necessarily the same direction as the current. Ohm's law: E equals IR. A current of I amps passing through a resistor with a resistance of R ohms produces a voltage drop of E volts, where E equals IR. So you'll see in a moment how we use that. Voltage increases come from passing through a battery from negative to positive. For example, if we pass through the battery in this direction, negative to positive, you can see the little positive up here. That will lead to a voltage increase. On the other hand, and then passing through a resistor in the direction opposite that of the indicated direction for the current also produces a voltage increase. For example, this is the direction of the current for I2, and if we pass through in the opposite direction, pass through a resistor, that leads to a voltage increase. Conversely, voltage decreases come from passing through a battery from positive to negative. So if we go in this direction through the battery, or if we pass through a resistor in the same direction as that of the indicated direction for the current. So for example, current's going in this direction. If we pass through the resistor in this direction, that will lead to a voltage decrease. And we calculate those voltage decreases using E equals IR. Here's how we use it. Starting here, the sum of the voltage changes is going to be negative 7I2 plus 10 plus 6 minus 8I1, and that will equal 0. Here's why. When we go through, again, we're going to go through the circuit like this. We're going to go through the loop like this. So we're passing through the resistor in the direction of the current, the same as the indicated direction of the current. That leads to a voltage drop. And the voltage drop is going to be, using E equals IR, the voltage drop is going to be I, which is the current, I2, times R, the resistance, 7 ohms. So E equals IR is 7I2, and it's negative 7I2 because we're passing in the same direction as the indicated direction of the current. In the same way, we're going to go through this battery in the direction of the current. Well, we're going from negative to positive, so that leads to a voltage increase. We're going through this. Next, we go through this battery, again from negative to positive, voltage increase, 6 volts. And then lastly, we go through this resistor, and we're passing through it in the same direction as the current, the indicated direction of the current, I1. And so the voltage change is going to be 8I1. In this case, it's a voltage drop because it's in the same direction as the current. Okay, and that has to equal 0. Let's use E equals IR in the other loop, in this loop here. Okay, we have negative 15I3 because we're passing through in the same direction as I3. And the resistor is a 15 ohm resistor, negative 15I3. Next, we go through this battery. Oh, now notice we're going from positive to negative. That leads to a voltage drop. And then lastly, we're going through this resistor in the direction opposite that of the indicated direction of the current. So that's going to lead to a voltage increase. That will be 7I2. We use Kirchhoff's voltage law in the small loops to obtain equations. A big loop, like if we did this one, that just incorporates the smaller loops, and it leads to a superfluous, an unnecessary equation. Then we use Kirchhoff's current law and nodes to obtain the other equations. Kirchhoff's current law: the sum of the currents flowing into a node equals the sum of the currents flowing out. Let's take the node in the center of the top of the diagram. I1 equals I2 plus I3. So the only current flowing in is I1, and the only currents flowing out are I2 and I3. So I1 equals I2 plus I3. What goes in must come out. So here are three equations. Let's get everything on. So you simplify them, get everything on one side so that they look like this. Find the augmented matrix, and then get it in reduced row echelon form. the reduced echelon form looks like this. So for example, our current I1 is going to be 1.0036. And similarly, I2 is going to be 1.1388. I3 equals negative 0.13523. And those are in amps. They're all measured in amps. If the value of the current turns out to be negative, then the current is really flowing in the direction opposite of that indicated in the diagram. So notice here, I3 is negative, which means I3 really isn't flowing in this direction. It's flowing in the opposite direction, but it doesn't mess up any of the calculations we did earlier based on the direction of the current. Everything's fine. Now let's determine the current I1, I2, I3, and I4 in this circuit. Okay. The top loops are the same as in the previous problem. All I've done is add this circuit at the bottom. Why don't you stop this, take a moment, and see if you can figure out what the voltage changes are going to be when we start here and go all the way around. Or if you're not ambitious enough to do that, I'll just tell you what the answer is. Let's consider the voltage changes in the bottom loop starting at the top right corner. In other words, starting here, we're going to end up with negative 20I4 plus 60 equals 0. That's because we have a voltage drop. We're moving in the same direction as the current, I4, passing through the resistor. So that'll be negative 20I4. That's the voltage change. And then we're going through a battery from negative to positive. So that's going to be a voltage increase, plus 60. Negative 20I4 plus 60 equals 0. So here are the four equations we end up with. Get everything on one side, and get your matrix in reduced echelon form, and the solution turns out to look like this.